Hello, everyone. Welcome to today's webinar on creating on-demand service virtualization environments. I'm Pamela Deason, Head of DevOps Product Marketing here at Broadcom. Today's webinar is actually going to be led jointly by Carl Miller and Uttam Anand. They're both client services consultants and experts on service virtualization. Now, during the presentation, you are muted, but you are able to enter your questions on the tab. At the end of the presentation and the demo, there will be a demo, you will be unmuted and you'll be able to ask your questions directly of either Carl or Uttam. The presentation is going to be recorded, and afterwards I will be sending out a link to the presentation to everyone who is registered for the webinar. Also be aware that in the handout section, there's a PDF version of what is being presented today, so you are able to download that as well. So now I'm going to turn it over to Carl. Carl, for you to start our presentation.
Great. Okay. Turn off the webcam. Okay. So as it says here on the first slide, we're talking about creating on-demand service virtualization environments. I'm Carl Miller. Uttam Anand and I are going to be doing this. So first, let's look at what we're going to talk about. Here's our agenda. For people that have not done service virtualization or are a little fuzzy about it, I'm going to do a very quick overview. Then we're going to talk about the benefits of on-demand virtual service environments. I'm going to go over some different methods to implement those and example architectures of creating on-demand virtual service environments. Uttam is going to lead our demo using OpenShift. And then we're going to review some of the use cases for doing on-demand services, followed, of course, by questions and answers. So let's get going. First, quick review of service virtualization. What is service virtualization? Well, it's having everything you need when you need them. So developers, testers, you're working with Internet of Things, mobile, SaaS, cloud, partner ecosystems. And you've got all these systems, but they depend on back-end services. These could be big back-end things. They could be third-party and APIs, microservices. Normally, you're going to have some kind of orchestration layer, middleware, etc., linking all those. But what we can do is, using service virtualization, we can virtualize, simulate intelligently all of those back-end systems, those services, etc. So that makes your integration testing much easier. We've removed constraints. You don't have to worry about not doing this because it isn't available or scheduling, etc. We can simulate web services, middleware, third-party, APIs, mainframe. You can do performance testing, component level performance testing of your piece of the application, and you can do negative testing, which is hard to do with live systems. This allows you to shift performance testing left in the SDLC. You do it much earlier. That gives you faster time to market. You have always available resources. You don't have to wait on somebody to complete something or something to be available. You can speed up your software development by at least 50%, sometimes more. And that gives you better quality. You can test sooner and more often. You're going to find out defects a lot earlier in the cycle, which means they're easier and cheaper to fix. So that's a quick overview of service virtualization. Now, we always get asked this question: does service virtualization work in the cloud? And the answer is yes. Customers currently have SV deployed in AWS, Azure, Google Cloud. I actually do almost all my demos in Google Cloud or the other environments. Private clouds. Container deployment in cloud is also supported. Docker, Kubernetes, OpenShift. And OpenShift is where we're going to be doing our demo today, up in AWS. So why on-demand virtual services? Well, it's because of this. what happens when a team wants their own VSE or virtual or environment? So typically, I've worked with a lot of customers and they're like, oh yeah, we got to get the requirements. We got to fill out the infrastructure request form. And once we submit it, it usually gets returned asking for more information. So we fill out those more details and then eventually it gets approved. And after it gets approved, 2 weeks, 4 weeks for provisioning, then they have to install service virtualization. And then they find out that the firewalls weren't rules weren't done and they have to redo those. So, yeah, it can be a month or two before they get a virtual service environment for the team that requested it. So what we're going to show today is how you could do on-demand virtual service environments and basically short circuit this entire process. And the benefits of this are it makes it easier to integrate with your continuous integration. Gives you much more efficient use of your on-premise or cloud infrastructure. You can use virtual services without have a lot of VSEs infrastructure up running constantly, but not always used. You could even enable self-service. Once you get these are all configuration files. These can all be automated processes that could be either scripted, some kind of CI engine. We use Jenkins a lot, but have other teams that use GitLab. So those are two of the big ones, but you can do it yourself with scripting or almost any kind of automation tool. And finally, it makes patching and updating a lot easier because you're bringing these things up and down as needed. So what are some of the methods? So first is virtual servers. It's a very familiar interface. A lot of people don't find it as easy to automate creation and installation of SV, although we do have a silent install. If you look in our documentation, and the link will be in the handout, you can use a silent install file with a configuration file, and this allows you to do that silent install, but it's just, you've got to bring up the virtual service environments, the servers. Docker Compose, that's easy to automate. Our documentation, we have a documentation, and if you look at that and you get a Docker environment, you will see how easy it is to bring up a system. Kubernetes, same thing, very easy to automate. The documentation is, we've got documentation on it. And finally, OpenShift, which is what we're going to be showing in the demo today, also very easy to automate. We've actually supported Docker containers for quite a number of years with service virtualization. So let's look at some architecture. All our components here, the Identity Access Manager, the Enterprise Dashboard, Catalog, Registry, Portal, Coordinator, Simulator, Virtual Service Environments. The only thing we really don't have in images is the broker and workstation. We don't provide those images. So let's first look at if you did virtual servers. You could do virtual servers where you have a standing enterprise dashboard with, say, Identity and Access Manager. It's got their database, maybe have a standing registry with its DB, registry DB, performance VSE. And then you have teams. You have VSEs for these teams. So if you need one, you automate bringing up a virtual machine, loading appropriate operating system that we support, and then loading dev test onto that using our silent install method. And that can be automated so you could bring it up for a couple teams and bring them down when you don't need them. So that's with virtual servers. Another option is hybrid cloud. So you have enterprise dashboard, Identity Access Manager, you may have a registry portal, some VSEs up permanently, but then using Docker, Kubernetes, whatever, you can actually bring up an entire system. bring up the registry and the portal in separate containers, as many virtual service environments as you need, coordinator simulator, and you can actually, if you look at our Docker Compose and Kubernetes, it talks you through doing all this. Alternatively, you could have a registry portal up in virtual machines. Maybe one performance VSE, and then you bring up as many container VSEs as you need. I've actually done this before for training environments, where I brought up 12 virtual service environments to train a group of people so that they could each have a VSE for their team and work with that. So this is using a hybrid, because you can mix and match. You can have physical, virtual machines, and containers all can work together. And then you can bring them down as needed. The only thing a broker is needed for is agent-based virtualization. So at this point, I'm going to turn it over to Uttam to talk about the OpenShift environment.
Sure. Thank you, Carl. Let me share my screen. Do let me know if you can see my screen.
We can see it now.
Okay, thank you. So, hi, my name is Uttam, and let me just go back to the slide. So today I'll be showing you a demo on Rosa cluster. Rosa cluster is nothing but Red Hat OpenShift cluster on AWS. Okay, so as you see in this presentation that we have deployed basically the dev test on an OpenShift cluster, and the architecture will be the same in also in the Kubernetes cluster as well. Okay, so as you see, we have created a dev test namespace, and all of the pods, basically the different components of the dev test are deployed in this particular namespace. Okay, so as you see over here, we have virtual service catalog, identity and access manager, enterprise dashboard, registry, portal, configuration server, virtual service environment, coordinator, and simulator, right? And also we have the persistent volume attached to this dev test. Okay, and I'll talk more about persistent volume later, but just I'm telling you that we need a persistent volume as well. And each of the uh, each of the components like dev test, each of the components of the dev test like enterprise dashboard, IAM, and registry will have requires a database, a SQL database, right? So moving on to the next one. So as Carl told that a lot of customers have their dev test environment in different clouds, right? So hybrid cloud basically. So suppose in an organization there are like 3 or 4 groups working on dev test, and each of the groups have their own registry, right? So this is the architecture which they have to follow basically. So in one of the namespace, what we suggest, you should keep the common dev test components like the virtual service catalog, IAM, and enterprise dashboard. And these pods will have their own persistent volume for enterprise dashboard and IAM. Okay, and they will be having their own database for connecting to it. Okay, SQL database. So for the group one, maybe we can have a different namespace where they can deploy their own portal, registry, configuration server, and VSEs. So they can spin up a number of VSEs. So as you see here, we have like 4 of the VSE for team A, team B, team C, and team D. So, and they will be having each group will be having their own persistent volume for their registry. Okay, and they will be having different different sorry Yeah, so they will be having different separate uh, database for their registry. So same in this case, group 2 will be having their own set of registry configuration server portal, and they will be having a number of VSEs. Here is group 2, team A, team B, team C, team D. Okay, so moving on to the next slide, and also I just wanted to let you know that we have created the automation for deploying the dev test using the Helm chart. So this Helm chart package is available on our you can get it from our Broadcom support portal. So I will show you how to get that package also once I go into the demo part. So, as I told you that these are the dev test components or pods, you can say, or services, you can say. So configuration server are there, IAM is there, enterprise dashboard, registry, portal, virtual service environment, coordinator, simulator, and virtual service catalog. So these are the 9 components which will be getting deployed on the OpenShift. Okay, so I will discuss about what are the prerequisites for basically installing deploying dev test on your OpenShift or Kubernetes cluster. Of course, you will need an OpenShift cluster. In my case, I have a Red Hat OpenShift cluster on AWS, so it's called Rosa cluster. So if you have, likewise, if you have a Kubernetes cluster, or like Azure Kubernetes service or Elastic Kubernetes service on AWS or Google Kubernetes service, so that those kind of cluster you will be needing. So for automating this dev test, you will need Helm chart 3 version 3. Okay, and then we also need a shared persistent volume which supports read write many access mode, right? So why do we need this persistent volume? Because VSE is like ephemeral, right? So it's like on demand VSE you are creating, and main goal of creating the VSE is to avoid the cost of your infrastructure, right? So whenever you require a VSE to run your functional test or any kind of testing, you can spin it up and then you can destroy it, right? So once you stop that VSE and your infrastructure is not being used as of now, but to retain those services, the services or any of your test cases and other things, those can be retained on your persistent volume, so that when you spin the VSC again, the same VSC again, all those services and other things are available to you. Okay, so that is why we need this persistent volume. The third thing we want is that you should have access to a registry, Docker registry, where the images are being pushed, right? So the first access you need to the Broadcom repository. So you will need some token and access to that. So once you pull that image from Broadcom Docker registry, you have to push it to your own choice of Docker registry. Either you can push it to your Artifactory or ECS, Elastic Container Registry, or any of your choice of Docker registry. So you will need that access. Okay, so the fourth access prerequisite is that you should have a database for IAM enterprise dashboard and one separate database for each of the registry in case you have multiple registries. So you can refer to the documentation for more specifics, but this is what we need, basic things we need for before deploying the dev test into the Kubernetes or OpenShift environment. So I will just give you a gist of what is the memory requirement for these Docker images. So configuration server will be using around 225 megabytes of memory, IAM 1 gigs, registry 2 gigs, coordinator, simulator, VSC half gig, and portal will be using 2 gigs, and again virtual service catalog will be using at least like half a gig of memory. And the size of the images which you have to pull from Docker Broadcom Docker registry is these. So configuration server is around 625 megabytes. IAM is 1.2 gigs. Lisa 2.6 gigs. Portal is 2.2 gigs, and virtual service catalog is around 1 gig. Okay. So now I will be showing you the demo. So let me go into my Visual Studio Code. So as I told you that we have automated basically the dev test using Helm 3 chart. Okay. So and also I have deployed dev test as of now, but I will show you how you can spin up the virtual service environment on demand. It's very easy to do that, right? So you have to download the Helm package, the DevTest Helm package from our Broadcom support site. So Helm repo. So this is what you have to add. So Helm repo add and dev test. Then you have to pass on the credentials. So my username is this, and the token you will get from your support from Broadcom support site. And that's what this is the URL from where you can get the dev test Helm package. Okay, so this is what you have to execute, and all the documentation are there on the tech docs for of Broadcom. Okay, so already have downloaded it, so it's already with me. Okay, so so basically it will be having all the necessary parameters and the config files and other things for deploying the dev test into the OpenShift or Kubernetes cluster. So I'm just taking one example. So why we have automated this, right? So we wanted basically to make the customer's life easier in deploying this dev test into the clusters, right? So what we have to do here is that this values.yaml is there in the Broadcom SV Helm package, and they have all the configurations over here. Okay, so like global, in global we have the key store, trust store, certificates you can give the path to it. Okay, then what kind of load balancer do you want to use, right? So this by default what we have provided here is Nginx. Okay, so Nginx, but I will show you when I deploy the OpenShift cluster, I have used the OpenShift cluster. So this is the static currently static YAML file for values YAML, but you can override these parameters from your YAML file. So suppose, because you will not be using the same load balancer, right? In my case, I'm using the OpenShift, so I have to change it, right? And the platform, maybe for someone it will be AWS or Google Cloud, right? So those kind of things you can give over here. So everything is parameterized. Okay, so you have to give the storage class name, then what repository we are using, then you can give the repository like the Docker registry, a username, access token over here. So those kind of things are here. Then you can give the IAM database password. These are the encrypted password. So this is not the actual password. These are the encrypted in base 64. Okay, and then you have to run all these pods, everything as a 1010 user. Okay, then coming into the part where we give all the details uh, related to the pods, right? So here it is. So configuration server, right? So configuration server, we are giving the image name and the tag name, whatever tag you have provided in your Docker registry. So that you will give the default properties and everything over here. And then also you can set the limits of what amount of CPU and what amount of memory you are trying to allocate it to this particular pod. Same way you have to give for IAM also. So the image name and the tag name, and also you can provide here the database name, right? So database name is IAM. So in my case, I have the different name or different different URL, right? So that also you can configure. So these are all the default things which we have in the values YAML. So once you try to deploy, you can create another YAML file. Basically here you can give whatever parameters you want to change. So I have changed the load balancer type from Nginx to OpenShift, platform to AWS, cluster name and domain name I have given. I have given the image repository name over here. I have given the access token. So all the parameters, whichever needs a change, that I have given. So here also, here like registry database, right? So database I have given, which I have installed in on the Amazon AWS cloud, right? So in same way I've given for IAM and enterprise dashboard. And I want to deploy a particular virtual service environment like VSC pod over here. So I have given the configuration for VSC here. Okay. So the name I have given VSC-prod and then VSC prod, and then I have given the minimum like the port range basically. So I have given like 500 ports allocated to this particular virtual service environment. Okay. And this port is basically on which this particular VSC will run. So I have already deployed it. So I will just show you what is the command which we use to deploy uh, basically this whole dev test, right? So this is the command helm upgrade install dev test, the name and the namespace I have given the dev test. If it's already doesn't exist, it will create a namespace, but if it doesn't, if it is already there, it will not create. Then I have provided basically the values, the default values YAML. So whatever doesn't need any changes, that will be there. And then I have provided my custom values YAML file. Okay, so whatever we have given over here, so these all changes will happen in the values YAML. So it will overwrite all these parameters of values YAML. So this is the command which I use basically uh, to install or deploy DevTest on OpenShift cluster. So I'll just show you what all pods which we have right now. So as you see over here, we have these pods already created. Okay, so so 1 2 3 4 5 6 7 8 9, right? So but in the images you saw that there we have only like 5 or 6 image, right? So this Lisa image will have basically the registry image, the simulator image, the coordinator image, and few others, so that you don't confuse with what it is, right? So these are all the 9 pods which will come up over here, and I will show you, like currently we have one VSC over here. So let's go in the dev test uh, portal, and I will show you how many numbers of VSC you have currently. Okay, so I'm going over here in the dev test portal, and then I will show you the virtual service environment. So currently I have only one VSC available here, which is VSC prod. Okay, so now I want to create an on-demand VSC for a dev team, suppose. Okay, so let's go in the YAML file again. So I have created another YAML file, um, and I have just given these configurations for virtual service environment. Okay, so I have given the name of this virtual service environment as account, then the VSC, then which team it is belongs to, like the dev team or the QA team, you can provide over here. And then I've given that, okay, this particular VSC belongs to team 1. Okay, so this is the name which I have given. I have given a port to it. Okay, and I have given the port on which basically this particular VSC will be deployed. Okay, so let's go and install it. So Helm, so same way how I installed DevTest, I will be installing this particular VSC on demand. Helm upgrade. So this is the command by which I can deploy basically this particular VSC on demand. Okay, so Helm upgrade. We have given the name of this particular Helm, then DevTest, and then namespace. We have given DevTest, and then the default values YAML I have given, and then I have given the custom YAML file. So custom YAML file is nothing but the new VSC custom parameters, whatever we have given over here. Okay, so I will just enter, run this command, and it will tell you that, okay, this dev test VSC dev does not exist. So it deployed it. Okay, and it deployed on this. So now if I go and get the pods over here, so you can see that this particular account VSC dev team 01 has been created for that particular group. So now if you go back to this dev test portal, you can see that it will take a moment. Let me just log out and log in. One second. Or Carl can show you that. So let Carl can show you. So Carl will run some virtual service on this particular VSE and show you how to run the test cases on this. So Carl, over to you.
Okay.
Let me give you back the control. Did you get the control back?
Yep.
Okay.
There we go. And I'm also in that portal, and as you can see, it's come back up. The virtual service environment is registered now. You can see the name, ACCT VSE Dev Team 01, and the host. So now that this virtual service environment is up, we can actually treat it just like any other virtual service environment. I'm going to go open up a pipeline I have, and I'm going to create build with parameters. And so pasting in, so I've got my VSE server, I've got an API. This is the API endpoint to run the APIs. I'm just using the different APIs. And now I've got the VSE host, and I'm going to click build. So what we're doing here is, since we've got a virtual service on demand, you can provide those, that can be provided to the team, the test team, development team, whatever, and they could be using this in their pipelines. I'm cleaning my workspace and I'm retrieving files from GitHub, in this case, request response pairs, some configuration information for my virtual service. I'm grabbing what's up there, checking to see that the virtual service environment is up and running. If a virtual service with that name is already existing on that VSE, I'm going to delete it. And then the next step is we're going to create the virtual service from request response pairs, and we're not specifying a port. So we're going to let the system choose an available port for that virtual service to run on, but it returns that in the response once the virtual service is instantiated, and we can use that. And I'm writing a configuration file for the application to use for its endpoint. And then after that, we're going to run a test against that virtual service. So we're creating that virtual service from the endpoint. If we go over to the portal here and refresh this, we can now bring up that virtual service environment. There we go. And you can see we actually have a virtual service up and running on there. So, sorry, we've got a recording going on. And now it's up and running. So we've got this. I'm going to take that off and click refresh. And we're already running our tests. So we're already getting transactions into this. So as you can see, it's running on this port. We've got an endpoint, fully qualified domain name. So we're able to run these, treat these just like any other virtual service environment. So that's, now you could actually have, now I'm going to undeploy this virtual service as part of my package here. I'm going to stop it. I'm going to undeploy it as part of this. So it's actually starting to stop right now. So if I click refresh, it's still running. One more refresh. And let's see, is that done yet? Yeah, it stopped. Okay. So go here and click refresh. There we go, it's offline, and now it'll be undeployed. However, any virtual service you leave running when you bring down this virtual service environment, that service will be available. So we've been able to complete that, and we've been able to run this without run this treated just like any other virtual service environment. The only other thing, we wanted to show you the Helm charts and how that was done. Otherwise, we could just add this in and bring up the virtual service environment with the appropriate name, get that, and then run this within it. So you can automate bringing up that virtual service environment, deploying virtual services to it, and dropping it once you're done. So let's go back, and we've done the demo. We've talked about that. Let's look at the use cases. First use case, continuous integration, continuous deployment, because you can automate these. It's Helm charts, placeholders can be used to build those on the fly and run those. You can create virtual service environments for development, for new teams, new projects, new branches, break fixes. You can simulate all the backend systems that are constrained, unavailable, or being developed, because you can bring these up on demand, load in legacy virtual services for legacy systems, and then for the new systems that are under development. This allows you to test in a clone of the production environment. That's a key piece of continuous integration, continuous testing, is you want to test in a clone of the production environment. With virtual services, you have test environments as code. You can deploy all the dependencies needed by a component or application as virtual services. These on-demand virtual services are going to allow you to do component level performance testing. You notice I was running like 150 transactions against a component pretty quickly. You can do you can do performance testing of a component in isolation. You can virtualize each dependency. So if I'm working on this application here, I can virtualize all these dependencies with the appropriate response time, so that I know after my testing that my component here can work on its SLA. It will work in its SLA. And I can test graceful handling of what happens if a dependency does not meet that SLA. So, logging, notification, etc. So that's a key feature of this. Great use case. On really isolated application testing using virtual environment. You've isolated that application, virtualizing all its dependencies. You can conduct load and stress testing, breakpoint testing, figure out what the limits are, configuration, do configuration changes, say in a virtual machine, make a difference. Test all those error handlings that are very difficult to get otherwise. But people say, hey, we're doing microservices. We can just bring up all these services. Well, why virtual versus live? Well, with virtual systems, negative testing, it's hard to do with live systems. And it's very difficult to make them do errors. With virtual services, if I send in count number 54321, I know I'm going to get back a 500 error because the virtual service is going to turn a 500 error. So I can make sure my system can handle a 500 error. I can have all the error codes needed in the virtual service and test those. Very hard to do with live systems. And negative testing, where it doesn't send anything back at all, or corrupted data, edge cases, corrupted data. Those are hard to replicate with live systems. And chaos testing. What happens when a dependency goes down? Well, with virtual services, I can have one virtual service as a primary and another virtual service as the backup secondary. And so I can shut down in the middle of the test using the APIs. As you just saw in that Jenkins one where I sent the API command to shut down to stop that virtual service, I could stop the primary and see if the application switches over to the secondary gracefully. So those are all things very hard to do with live systems. Because if you shut down a live system, maybe another team was using that and they weren't prepared for it to go down, and you may have broken their endurance test halfway through their 24 hours. They won't enjoy you in breaking their schedule. So those are some reasons why. What are some best practices? Use your continuous integration tools and automate. You can enable self-service with guardrails. Jenkins pipeline I showed, any kind of pipeline will do. You can have those with certain parameters that come into it, and the other ones are set in. You as the center of excellence can control those. So those you can give guardrails, but you can enable self-service. You can automate the deployment and control of the virtual services. Naming conventions. You notice that we had a naming convention for that virtual service environment. Gave 4-part naming convention, and you can have those, and they're great because that helps you identify who's using what. VSE names should maybe have teams, systems, or functions. Numeric if you've got more than one for that team, system, or function. In the virtual service name, include the application name version, definitely in the virtual service, maybe the team that developed it, maybe the version of the virtual service. There's all sorts of things you can do with this, and we're going to be putting out best practices on our community site later on, giving some examples of those best practices. Source control management. In my pipeline, I grabbed everything from source control to do my systems. That would be my VSM, VSI files, config files, data files, RR pairs, WSDL, Swagger, Open API. All those things, virtual service assets should be in source control management. You could also put your configurations, those Helm charts of the clusters and the on-demand VSEs, those should also be in source control management. Artifact repositories are absolutely great, especially for legacy services that don't change, haven't changed in a long time. You can put those in as MAR files because they'll always be on the same port or whatever, and you can use those with virtual service environments. So teams could grab a whole bunch of legacy services that everyone uses all the time and drop those into their virtual service environment. Enabling technologies, our virtual service catalog. If you don't have that up, you might consider it because it allows teams to look at what virtual services other teams have done, grab them so that they can just modify them a little bit and don't have to build from scratch. Source control management, I just mentioned the great things there. Your continuous integration tools, that enables self-service. So to recap, on-demand virtual service environments, they're easy to integrate with your continuous integration. They give you much more efficient use of your on-premise or cloud infrastructure. You can use virtual services without having a lot of VSE infrastructure running constantly. I think it's a great way to enable self-service because teams can bring things up, run it only when they need it, and bring it down. It doesn't take very long for things to come up and come down, so you can use those. For the operations teams, it makes patching a lot easier. You're able to configure, you're able to patch systems, you're able to use containers. So it's going to make patching and upgrading a whole bunch easier by using these containers. So we have some resources available, and these, if you grab the handout, you'll be able to see these. You'll be able to click on the links in the handout. We've got our product documentation. That's where you can see things like our deploy dev test in OpenShift, our Kubernetes, our Docker, all these kind of things in our documentation. Great documentation to help you out there. We have a community. Most of you are familiar with that. And we also have the Broadcom Academy with the courses to intro to service virtualization. So at this point, we're ready for any questions that people might have. Hopefully you've put some in the thing.
Yeah, I've seen one or two come through, so I wanted to share that with you and Utam. The first one here, so someone has asked, how many services can we deploy in one registry?
Good question. We actually have customers that have up to 50 virtual service environments connecting to a registry. They've actually gone a lot higher than that, but we find that keeping it around 50 or so virtual service environments, but it has to be an adequately sized registry with enough CPU and memory to handle that. It does depend on what kind of services you're running and how and the traffic onto the virtual service environments. Now, virtual service environments, depending on the size, how many CPU you've given it, virtual CPU you've given it cores, and the memory. But we have a lot of people have 100 or more services easily running on a virtual service environment. It depends on the traffic into it and whether it's configured for performance VSE or not. If it's just functional virtual service and people aren't doing performance, a whole bunch of automated load type testing, concurrency type testing against it, you could easily have 100 virtual services on it and testers running tests every now and then, every so often. Easily have 100 virtual services on there. Functional VSE does have a limitation of 10 concurrent transactions, 10 TPS. After that, it starts queuing, but that's a lot of transactions per second, actually, 10 TPS. So, it kind of depends on your services, but it's very, very flexible. And although Utam showed you the memory requirements, that's the minimum memory requirements. You can actually, using the properties files that would be on the persistent volume, you can give those virtual service environments more memory. And for a functional one, obviously you would.
Okay, thank you, Carl. Another one that was keyed in during the presentation, how much capacity do we need at the namespace level?
Utam?
So capacity at the namespace level, there is not as such some capacity, but the thing is like you should have a cluster and you should have a separate namespace for your dev test and the minimum whatever you saw, right? So you cannot allocate actually the capacity to a namespace, but you can allocate the capacity to the pod or the services or the deployment, right? So the minimum whatever I showed you in the slide where portal used to take like 2 gigs minimum memory, so that you have to at least have it, right? So that's hope this answers your question.
Yeah, and that goes back a little bit again to if you have so what we've given you is the minimum for that, and that handles a certain number. But if you decide to run about 25 virtual service environments against that registry, I would at the very least double the memory for that and double the memory for the portal. So you could you're going to have to, depending on your traffic, because if you have teams from all over the world running against it all the time, it's going to need a little more horsepower than if it's only during, say Pacific. Pacific time is your team's only in Pacific time, and they're the only ones using it. So you have to do a little bit of tuning for yourself, but you'll be able to see that pretty easily. And the monitoring stuff that you get in any kind of cluster, any of these cluster systems should help you out with that. Because the nice thing is you can
So
you just change the configuration and redeploy.
Yeah. So thank you, Carl. So basically, administrator can create a resource quota for your namespace, and that resource quota would be the minimum resources which it requires, and double it basically, and it will depend upon your use cases, right? How many VSCs you want to deploy, how many virtual service you have to deploy, so it will depend upon that, but from the minimum you should double the resource quota for your namespace.
All right, and we actually have another one. So each virtual service runs under its dedicated pod or runs inside the VSE.
Can you come again,
Each
Amit?
virtual service runs in the VSE.
Yes.
It runs in the VSE. Each transaction coming in is a thread, but the virtual service runs in the VSE, and the VSE is in its own pod, and it connects to the registry, which is running in a pod, and they're all in the same namespace.
And yet another one. We have quite a few questions.
Great.
Yeah, great. Exactly. Will the VSEs created by users, wait a minute. Will the VSEs created by users, are they only visible to them, or can they be seen by other users too who are under that registry?
Great
it,
question.
it will be visible to everyone, I guess.
The virtual service environment could be visible to everyone. However, you can take advantage of our resources and resource groups availability. If you look in our documentation under resource groups, a resource group, a virtual service environment, when it's created as a resource, it can then be assigned to a resource group, and that resource group can be accessed only if the role the user is coming in as is authorized to that. Since one of the other best practices is use your LDAP, integrate your IAM with LDAP, so that as someone comes in, their user ID is associated with an LDAP group, and we've assigned a role to that LDAP group. So the resource group could be patterned after their development team. So you could have, if you have a team, dev team 1 in LDAP, you could create a dev team 1 resource group using our identity and access manager and our access control in the portal. And then when they bring up a virtual service environment, that would be assigned to that resource group. So at that point, only those people in that resource group, and of course the dev test admins, would be able to see that resource and interact with it. So it's a little bit extra, but those are all API calls, so that you can do those things. You can automate those as part of creating that virtual service environment. So hope that answers your question.
Just as a reminder to all of you, you can unmute yourself if you would like, if you choose, and ask your question. But it's fine if you're typing them in. That's also fine. I do have another one here for the two of you. It says, so what are the requirements for a database? Is it on-prem or cloud, or can it be both?
Any hybrid. So the database can also be on cloud, or it can also be on-prem or anything. So it's hybrid.
It can be on cloud, it can be on-prem, and it can also be in a container.
Yes.
Okay, so here's a question related to that. Is there any concern on licensing when you move to the cloud?
No. The only, well, there most of what your licensing is reflected in your enterprise dashboard. So we prefer you to have the enterprise dashboard up and running at all times, and it should go to a database where that information is persisted, say on a persisted volume. But if you remember, your licensing is by power user, those people that create, edit, and deploy virtual services, and those are concurrent users. Those will be tracked in your enterprise dashboard. Your functional transactions against functional virtual service environments, which are again tracked in the enterprise dashboard. The only thing I would be careful about is concurrent performance virtual service environments. Performance VSEs are concurrent license. So if you're licensed for 2 performance VSEs, you can have one on-prem, one in cloud. And if you shut down the on-prem, you can bring up another one in cloud and vice versa. The enterprise dashboard will help you because it shows you the max you're using and how you're using it. So it will help you out on keeping control of that. Really, but because of the concurrent usage of power users, and they're only used for, so as this team does this, when they create a virtual service environment, they bring up a container and it brings up a virtual service environment. We allow you as many virtual service environments as you need. That's under a power user. As many functional virtual service environments as you need. Then a power user license would be used for the time needed to create the virtual service, as I did from request response pairs. At that point, then, you don't need a license. You don't need a user license to run the test. For example, I just used up 150 of my functional transactions, and those transactions count against functional transactions out of your transaction packs. And each transaction pack is 23,000 per month. So the virtual service enterprise dashboard takes care of keeping track of that, and you just use that to monitor your usage. You probably shouldn't, it'll probably just make you much more efficient use of your environments. Hope that answers your question.
Great. The next one is the Docker image. Has it been validated for security vulnerability? And how often is the image being released?
Yes, so the image basically has been vetted for the security things. So we have been scanning the images and removing the vulnerabilities. So yes, so the answer of your question is yes, we do that. Okay, and in case you guys are using some other, like some tools basically to find out the vulnerabilities, do let us know, and we will vet that vulnerability and try to resolve it if it is if it is feasible. So yes. And regarding the image, we release it. We don't have a timeline on like how often we release the image, but if there is some changes, or if we remove some vulnerabilities and other things, we create an image and push it to our Broadcom Docker registry. Hope this answers your question.
Yeah, so hi, this is Praveen from KP. So we have our own scanning, like we do the scanning for security vulnerabilities, and if in case we come across anything, any vulnerability, like how soon you would be fixing it? Do you have any timeline?
It's going to all depend on what it is. It's going to all depend on what it is. I mean, it could go from a simple fix of something to say the log4j, which took a little while. Actually, that took a little while for everyone. So it would depend on that. But most of our customers pull the images down from our repository, put them in through their scanning process, and then put them into their own repository. but the fixing of it would just depend. However, the sooner you report it to us with details, the sooner we could the sooner we could work on it. Although we're going to be looking at them also. So.
Okay.
And because sometimes also there might be a vulnerability there that's been reported, say with the open source component, but we'll take a look at it and say, hey, it's this part of the open source component, and we don't even get anywhere near using that, so it doesn't apply. It can't be accessed because of the way we use that open source component. So I can't give you an exact because there's a whole bunch of different permutations, as I'm sure you understand.
Got it. All right. And what are the bit versions? Like you have like 64-bit images, like both.
Oh, they're all 64-bit.
All 64-bit. Okay. Gotcha.
Yeah, I don't think we've had 32-bit for years, a couple years now.
Okay. Thank you.
Yeah, great. The one thing I would like to say is this, for your operations team, this is going to make patching a lot easier, because if you think about it, if you've got custom code, custom DPH files and jar files or whatever, you can load that code, those jar files, into the persistent volumes. And so you just have to load them in persistent volumes. You don't have to. And then when the virtual service environments or the registries, et cetera, are brought up from those, say the Kafka jars, you could put those into the persistent volumes where we're getting the lib files for these containers, for these pods. And as they're brought up, they will have those. So it will, instead of having to go around to the registry and then the 5 or 6 VSEs that you have up and running and put those files in there, they just all pull from the appropriate persistent volumes. It'll make patching, upgrading, that type of thing, deployment of custom code much easier, much more efficient.
Okay, so we are a few minutes over. I am going to have to apologize to those of you who have other questions outstanding. What we'll do, though, is take these questions and answer them via email. So we have your email, we know who asked the question, and we will answer it that way. It's been great participation today. Really appreciate everyone joining. And thank you, Carl and Uttam, for presenting with us today.
Hey.
And one more reminder, the PDF is there attached under the handout section. So if you want the PDF, all you have to do is download it. And I will be sending out a link to the recording as well. So thank you. Thank you, everyone.
Thanks. Thank you, everyone. Bye-bye.